Welcome back, everybody, to another Big Ideas lesson. Today, section 4.3, dividing polynomials. Now, last time we learned how to multiply polynomials. We also learned how to add and subtract them. But division is always going to be a little bit tougher. Even when we learned in elementary school how to divide, it was a little bit tougher. The good news is we're not going to be learning too much new stuff. It's just going to be a next level up from stuff we already know how to do. So let's go back to elementary school for a minute, when you first learned how to divide using long division. We are going to use long division to actually divide out some polynomials. So the first step is to make sure we all remember how to do it. So over here on the left, I have an example. You can feel free to look through this if you would like. But I'm going to show you all how to do long division again, in case you don't remember. Let's use long division to divide 479 by 7. So let's do this. 479 is called the dividend. It's what we're trying to divide. And we're dividing it by 7. That's the divisor. And our answer is going to be called the quotient. Step 1 is to look at the first digit of the dividend. So our first digit here is 4. And we're going to try to divide it by the divisor. If the dividend is smaller than the divisor, look at the first two digits instead. So we can't divide 4 by 7. But we can divide 47 by 7. We're not looking for an exact number here, but we are going to look for the next best thing. We're looking for the biggest number that we can divide as a whole number. So 47 divided by 7 isn't going to give us an even number. But we do know that 40-something divided by 7 will give us a whole number. We know, for instance, that 7 times 6 will give us 42. So the first step is to find a number, as close as you can, that multiplies to make 47. Here it makes 42. The next step, step 3, is to subtract the result from the digit and write the difference below. Well, the difference here, 47 minus 42, is 5. Good to go. So we know the first digit of our number is 6. What you do then is you bring down the next number, if there is one, and we start the process again. So what number can multiply 7 to get close to 59? This one's going to be a little bit trickier. But we may recall that 7 times 8 is 56. So if I write down 56 and I do the subtraction, we get 3. Notice how there are no more numbers left to divide. If we wanted to get a decimal, we could add a decimal point here and here, add a 0, and bring it down until we get our decimal. But instead, for this process, I actually want us to keep the remainder. Weird. We can just write R3 to show that there is a remainder of 3. So our answer is 68 with a remainder of 3, or 68 and 3 over 7. Perfect. We're going to learn how to do long division with polynomials much the same way. Before we can do so, let's first check to make sure everything is in standard form. So in example 1, we're going to use long division to divide this quadratic by this binomial, this linear. They're in standard form since our degrees are all in order from least to greatest. Like here we go degree 2, degree 1, degree 0, degree 1, degree 0. If either of your polynomials are missing a degree, like let's say we were missing our x term, we would actually physically write down 0x as a placeholder. We'll see this a little bit later. But for now, we're just going to do the basic problem. So we have x squared plus 8x plus 12 that we're dividing by x plus 2. This is a little bit weirder. It looks way more complicated, but the steps are still the same as what we learned in elementary school. So the first thing is, we look at the dividend. Sorry, y'all, still outside the school. So we look at the first part of the dividend, but instead of looking at the first digit, we're looking at the first term. It's x squared. Can we divide x squared by x plus 2? Or in other words, is there something I can multiply x plus 2 by to make x squared? No, there isn't. So we look at the next one as well. X squared plus 8x. If I'm comparing these two, is there something that I could multiply x plus 2 by to get x squared plus 8x? Well, maybe not the exact number, we can get close. If we multiply x plus 2 by x, watch what happens. X times x is x squared. And 2 times x is 2x. What have we just done? We've just started the long division. So with long division, with polynomials, the first thing that you are looking for is something that can multiply your whole polynomial here to make it look like at least the first term. So x plus 2 times x will give us an x squared plus 2x. Now, just like before, we're going to subtract it. What's x squared minus x squared? X squared minus x squared is 0, so those are fine. What's 8x minus 2x? Well, that's 6x. So we have a 6x here, and don't forget to bring down the next term. So we have 6x plus 12. And now we repeat the process. Is there something that I could multiply x plus 2 by to get 6x as the first term? Well, yes, x plus 2. If I wanted to get 6x from x, I should multiply by 6, right? So we can do plus 6. If I multiply x plus 2 by 6, I get 6x plus 12. And would you look at that? When we subtract them, we get 0. We have no remainder. We are good to go. We have just successfully done the long division. So, as a reminder, our goal is to get this polynomial to look like the first term of this polynomial. We want our x to be an x squared, so we multiplied by x. We multiplied everything by x, factored it down, then tried it again. We're going to get some more practice with this, so don't worry. So on the next page, we have the following. Sometimes you might be left with a remainder at the end of the problem. A reminder that a remainder is just something that's left over when we do the division. When you're left with a remainder, just add it to the end as your remainder divided by the divisor. So for this problem, if my remainder was 10, I would write it as 10 divided by x minus 2. I want you to try just this first one for a second. See if you can replicate the steps that we did on the last page. It's not going to be easy. None of this is. But the more we do it, the more practice we get, the easier it gets, just a little bit each time. Pause the video, see if you can set up and try this problem. And if you want to check in, you'll be able to play the video in just a second. Pause it and try it out. Hopefully we had a chance to try this one out. Otherwise, you were just sitting there in silence, listening to me wait for you for a couple of seconds there. Let's divide this using long division. So we want to set up our 12x to the 4th. But, uh-oh, am I missing something here? I'm missing a cubed term. I'm missing my x cubed. So I have to put in a placeholder. Remember, that was our one rule. Our rule is that we have to put in a placeholder. So I'm putting 0x cubed minus 5x squared. I'm missing an x term as well. See how there's a squared but no x term? So I'll put in a plus 0x and then my minus 3. This one's going to be a little bit of a longer one. We're dividing it by x minus 2. So, once again, we've got a binomial here, so let's look at the first two terms. What can I do to make my first term look like this first term? What can I do to make x into 12x to the 4th? Well, I've obviously got to multiply by 12 something, right? To get from 1x to 12x, I have to multiply by 12. To get from x to the fourth, though, I've got to have 3 more x's in there. So I'm going to multiply this by 12x cubed. The reason being, x times 12x cubed is 14x to the 4th, or 12x to the 4th. That looks exactly like this. So let's multiply it. X times 12x cubed is 12x to the 4th. But what's negative 2 times 12x cubed? That's negative 24x cubed. Negative 2 times positive 12 is negative 24. We subtract these out like we've learned to do. These cancel out, and we're just left with 0 minus negative 24. Be very careful with your negatives. It's minus a negative. And we know that minus a negative is a positive. So we get 24x cubed. We bring down the next term, negative 5x squared. Let's keep going, we're on a roll. So what can I do to x to turn it into 24x cubed? Well, I have to multiply it by 24, so I know that that's going to be there no matter what. But I also have to multiply 2 more x's in there. So I'm going to multiply it by 24x squared. 24x squared times x is, once again, something we already know. It's going to be 24x cubed. Oops, wrote that weirdly. But what's negative 2 times 24x squared? What's negative 48x squared? These x cubes cancel out, so we get a 0 there. Negative 5x squared minus negative 48x squared. Again, we get a minus negative, that's the same as plus. We get 43x squared. Let's take a look at the next one. We start off with 43x squared. I'm going to write this in black just so I can stay consistent with the way I'm coloring things. And we want to bring down the next digit. So we bring down 0x. We bring down our 0x. Again, what can I multiply x minus 2 by to get 43x squared as the first term? Well, here's where I have to multiply by 43x. So plus 43x here. If I multiply by 43x, 43x times x is 43x squared, so that's good. Those will cancel. 43x times negative 2, this is negative 86x. And if we subtract these, again, we have another negative here, right? Negative 86x is just 86x. We bring down our last term, which is negative 3. And we once again try to figure out what we need to multiply x minus 2 by to get 86x minus 3. We have to multiply by, yes, you guessed it, 86. 86 times x is 86x. 86 times negative 2, this one's going to be a little bit trickier to do. However, it's not that tricky. If we do 86 times negative 2, we get negative 172. Ooh, I ran out of room here. Sorry, y'all. But these cancel out. Negative 3 minus negative 172, well, that's going to be negative 3 plus 172. That's 169. So our remainder is 169. How do we write out a remainder of 169? Well, to write out a remainder of 169, our rule says to write our remainder over our divisor. So our final answer is going to be this quotient up here. I'm going to write it up here so it's a little bit nicer to see. 12x cubed plus 24x squared plus 43x plus 86 plus our remainder, 169, divided by x minus 2. And that is our answer. Wow, what a mess. That's going to be a trend that we see, is that long division is a little bit messy. But don't worry, I'm going to show you an easier way of doing these problems in a little bit. Trust me here. Before we do, I want you to try out this one now. Remember our rule. If you have a remainder, put the remainder over the divisor. Pause the video here. I'm going to just show the work when we come back. All right. There's the work for this one here. Take a quick look, see if you got it. Awesome. If you have any questions on these, let me know, because this process is not easy. Just because it's something we've done before doesn't mean it's easy. That's why I want to teach you a little bit of a shortcut. There is a shortcut here. It's called synthetic division. Synthetic division uses a lot of the same ideas. That's why I taught you long division in the first place. But you don't have to deal with as much thinking with this one. It's actually much more simple math. So synthetic division is a shortcut that allows us to divide in the same way, but where you don't have to worry about your variables and exponents. There is a restriction. It only works when your divisor, the thing you're dividing by, is of the form x minus k. So x minus something. Something like x minus 4 would be good here. Something like x minus 10 would be good here. Even something like x plus 3 would work, because that's just x minus negative 3. The key is it's got to be a binomial that looks like this. Can't have a number in front of the x. Can't have a squared, just like this. Most of the time you're going to be dividing things like this anyways. In fact, 99% of the time you will. So let's take a look. Let's use synthetic division to do this division, something that looks a little bit weird, a little bit cumbersome if we were to do it with long division. Step 1 I've done for you. Write the coefficients of the dividend in order of decreasing exponents. So this time we're not writing the whole polynomial 2x cubed plus 6x squared plus 29. We're just writing the numbers in front of all of them. But where'd this 0 come from? Well, any missing degrees will use the number 0 as a placeholder, just like how we did with this problem. We're just going to use 0 as a placeholder. You want to place your k value, x minus k, to the left of the coefficients. Since it's x minus 4, our k is 4. If it was x minus 10, our k would be 10. If it's x plus 3, we know we had to make it negative. It would be negative 3. Good first step. The first thing you're going to do is you're going to bring the leading coefficient down below the problem. You're going to bring this 2 down here. Then multiply this leading coefficient by the k value. So we are going to do 4 times 2, and we're going to put it right underneath this next number, 6. So 4 times 2 is 8, so I'm going to put it right here. There's my 8. Then add the coefficients together. 6 plus 8 is going to give us something different. So 6 plus 8 gives us 14. Cool. All right, and let me just write all this stuff down that we've done before. We know that this is going to be a 2 down here. We know that this was an 8 up here. We know this was a 14 here. Perfect. Now multiply the last sum by the k value. So our last sum was 14. Our k value is 4. We're just going to do it all over again. So once again, we multiply 4 times this number. Well, 4 times 14 is going to be a little bit tougher, but it's going to give us 56. So put down a 56 here. We add these two together. So 0 plus 56, that's just 56. And we write it down here. And we repeat this process over and over and over again until we end the problem. So now we got to do 4 times 56. 4 times 56 is going to give us 224. Well, 29 plus 224, it's a big number. It's going to give us 253. The key with this is the numbers in the bottom row are the coefficients of your answer, and the last number is your remainder. I just recommend writing it from right to left, actually, starting with the remainder and working our way up, so we don't have to get anything mixed up. So our remainder is 253 over, what was our dividend? Sorry, what was our divisor? X minus 4. It's 253 over x minus 4. Next up, we have this 56. Well, that's just going to be a whole number. Remember that it goes from remainder to just our constant term, and now we can start putting in our next terms. So after the constant term comes our x. This is just 14x. That's our degree 1 term. And last but not least, we have our 2. That's 2x squared. This is, believe it or not, our answer. 2x cubed plus 6x squared plus 29 divided by x minus 4 is 2x squared plus 14x plus 56 plus 253 over x minus 4. Really, really weird, but the process is so much simpler, isn't it? In fact, let's do some practice problems. I really like these, mostly because I'm a pattern type of guy. Like, I really like it when I can see a pattern going on, and this is just all patterns. So here's what I want you to do. I want you to see if you can try these 3 on your own. If not, I'll be walking through each of them since they're really quick to do. So, pause the video, try these 3 out. Hopefully feel free to pause the video and try it. Let's get started. So first thing we do is we make this big L here. And what we're going to do now is we're going to put in the coefficients of each term. And remember, if there's a term missing, we have to put a 0. So the coefficient of our x cubed term is negative blank, so it's negative 1. The coefficient of our x squared term is 4. But we're missing an x term, so we have to put a 0. And then our last term is 9. That's our constant term. In front of this, we put the k value of our divisor. It's going to be 3. Remember, it's x minus your k value. So if it's x minus 3, we put a positive 3 there. We start by bringing down our leading coefficient, negative 1. And now we begin the process. 3 times negative 1 is negative 3. Now we add them together. 4 plus negative 3 is just 1. 3 times 1 is 3. And 0 plus 3 is just 3. 3 times 3 is 9. 9 plus 9 gives us 18. So our answer here is going to be as follows. I like to write it from right to left. We start with our remainder. We do have a remainder of 18 over x minus 3. It's always over this. The next term is, we have our constant term. That's just 3. So it's like 3 plus this. Next up, we have a 1. That's 1x, which I'm just going to write as x. And last but not least, we have a coefficient of negative 1. That's like negative 1x squared. So I'm just going to write negative x squared. Done! That's our answer. Isn't this so much quicker than long division? It blows me away every time. On the next problem, we do it much the same way. We have an x cubed term, so that's going to be our first coefficient. our next coefficient, we see we have a minus x, but we're missing an x squared. So we put a 0 for the x squared, a -1 for the x, and a -7 for our constant term. Be very careful. What is your k value here? It's not 3. It's supposed to be x minus k. If we see x plus something, it means your k value is negative. So our k value is -3. It's going to make the problem a little bit trickier, but not so much that it's impossible to solve. So what's 2 times -3? Well, that's going to be -6. Now we do, 0 plus -6 is -6. Now we do -3 times -6. -3 times -6 is going to be positive 18. -1 and positive 18 is going to give us 17. Did my colors wrong, unfortunately, but it's all right. 17 times -3 is actually going to give us -41. So we're going to write -41 here. No, sorry, I messed up. That's -51. So even a math teacher can get it wrong sometimes. In my case, a lot of the time. -7 plus -51 is -58. So we're good to go. We end up with the answer 2x squared minus 6x plus 17 minus 58 over x plus 3. Again, normally I like to write it from right to left. I just wanted to write out the answer quickly. The last problem we have here, it's another one with the same number of terms. Our k value is 7. And our coefficients are 1, -13, 40, and 18. We bring down our leading coefficient of 1, and we start. 7 times 1 is 7. -13 plus 7 is -6. -6 times 7 is -42. 40 plus -42 is just -2. -2 times 7 is -14. And 18 minus 14 is 4. So our answer is x squared minus 6x minus 2 plus 4 over x minus 7. Done. We've had a lot of remainders with these ones. Let's try one that gives us a whole number. In fact, example number 5 is going to give us a whole number. The area of this rectangle is given by the equation area equals base times height. We know that area is base times height for a rectangle. If the area of the below rectangle is given by the polynomial 3x squared minus 15x plus 12, can we find the height? Let's write this out in an equation. So area equals base times height. Well, we know the area. The area is 3x squared minus 15x plus 12. And it looks like we're given the base as well. The base is x minus 4. But the height, we don't know. That's what we're trying to solve for. What can we do to get our height by itself? That's what it means to solve for, is to get it by itself. We can divide both sides by x minus 4. Because if we divide by x minus 4, that'll cancel out this x minus 4, right? H is just going to equal whatever 3x squared minus 15x plus 12 divided by x minus 4 is. This is where we can use our division. And you get to choose if you want to use long division or synthetic division. 99 times out of 100, I'm going to choose synthetic division. It's just straight up easier. There's almost no case I can think of where you would want to use long division, unless a problem tells you to use long division, which on the test you won't be given something like that. You'll be given just divide. So we write it all out. Our k value is 4. Our coefficients are 3, negative 15, and 12. This one's going to be a little bit of a smaller synthetic division problem. And we begin. Drop the leading coefficient down, then do k times your leading coefficient. That's 12. Well, negative 15 plus 12 is going to give us negative 3. So now we multiply again. 4 times negative 3 is negative 12. But negative 12 plus 12 is 0. Our remainder is 0. We don't have anything left over. If I was to write this all out, it'd be like 0 over x minus 4 here. Then we would have our negative 3 that we're adding to it. And then we would have our 3x, right? But notice here, 0 divided by x minus 4 cancels out. We're actually just left with 3x minus 3. That's our missing height. So there are some applications to this. We're going to get more into the practical uses of synthetic division a little bit later. But just keep this process in mind. It's kind of fun to do, in my opinion. If you would like some extra practice problems, on the next page, there's a whole bunch that you can do. A whole bunch. I will say, for exercises 12 through 15, we never talked about how to use synthetic division to evaluate something. We've never talked about how to do that. So you can just exclude 12 through 15. But everything else, totally reasonable to try out. With that said, everybody, that is the end of our video for today. Thank you all so much, and have a fantastic rest of your day.